All right, we're going to go over effective instruction, instruction in my content area, instructional sequencing, academic language, differentiated instruction and scaffolding, and the EdTPA central focus. So I've set up this PowerPoint so I'm discussing math instruction in every single slide. So I'm incorporating math into everything. So differentiated instruction means to provide multiple entry points into every subject or lesson. So these could be analogies, stories, numerical representation, visual explanations, dramatic interpretations, and essential questions. And as a scaffold, it's important to use a range of instructional modes. So I'm now going to bring this back to math. In math, it's common for us to use algebra tiles or base 10 blocks as manipulative to understand an equation. Students are used to listening to lectures, but providing them with fill-in notes is a great scaffolding form, or even whiteboards to practice whiteboard examples. And then bringing in readings from the real world to represent math in a real-world situation. And ask students to provide explanations or solutions or interpretations, maybe come up to the board and explain themselves. So the student is being the teacher. And Desmos is really great in math. Students are able to explain or see a graph online and see the differences between a variety of graphs. Differentiation instruction is also great in group formats and configurations. So having students get into groups of 2 to do an activity, or having them sit in groups of 4, or maybe in groups of 7 for an activity review, and each group is doing something different to review for this activity. You can have informal or formal groups where, informal, maybe they just get up to do their homework together. In formal groups, you're putting them together to maybe work on a group quiz. So technology is a large part of scaffolding. So maybe using an overhead projector to present some notes. Graphic organizers are available online. You can generate your own graphic organizer. And even the school website is so powerful. You can put all your notes on the website. You can create Screencast-O-Matic with just lectures and representing math. And then you can choose appropriate instruction to make technology useful in the classroom. So before even starting the class, you can give them clear instruction on the technology that they're going to use. And you can choose the technology that best fits for your lesson. So instructional sequencing. So I'm first going to go over the instructional sequencing, and then I'm going to talk about math sequencing. So before typically you want to introduce a lesson, you want to determine the student's current knowledge and skill level. So you can do this through pre-tests, diagnostics. You don't even need to grade them. Just turn it in, see what they know, even close assessments, or through formal or informal assessments. Maybe it's just at the beginning of class, you provide students with a warm-up and just walking around and seeing what they know. And maybe at the end of class, an exit ticket to do the same exact thing. So when you introduce a new lesson, you may want to describe or demonstrate each strategy or technique at the beginning, during, or after. So if I'm introducing a new lesson, a math lesson, I may want to show easier examples at the beginning and then build up to a more advanced example. And also demonstrating the language you want to use when writing or speaking. So introducing new vocabulary words or clarifying or summarizing vocabulary words is really important at the beginning of the lesson. Also at the beginning, let's just say at the beginning of the day you want them to get into groups. It's important to define the objectives and criteria clearly before you begin or teach the lesson or unit. So you can post objectives clearly, providing examples. These two are very important when beginning a unit, maybe a unit lecture. But maybe it's important it could also be important if it's group work. You can post the objectives of what you want the group to do. You can use a rubric. And then at the end, collect work or discussion questions. And then at the end of your instructional sequencing, maybe you want to give them opportunities for reflection through journals. Maybe they took a test at the end and you're going to give them time for quiz corrections. And math sequencing is very similar because in math sequencing, it's more of a day where you have students come up and present their work. And maybe you start with a student who doesn't know what they're doing. They'll present something. And then you want to build off of that student. So you have another student represent their work that maybe builds on the student who didn't quite understand. So having different students come up and present their work and having a student come up and build on that student kind of shows a sequence of steps to determine a math problem or determine a solution. So that's what's considered math sequencing. Now, how are we going to incorporate academic language? So you want to help students make connections. Connecting what students are learning to essential questions or big ideas, as mentioned, improves learning motivation and recall. So a way to promote academic language is maybe generating questions individually or as a class and having students respond to them. Maybe through structured note-taking, showing new words, promoting new words or academic vocabulary. Through study guides, maybe through charts. You can model connections between concepts for students. Maybe how, in math, how this representation connects to the graph. That gets you to use academic language and maybe new words. Websites such as Khan Academy, or using hypothetical questions to engage students in their learning. So with academic language, you want to build on students' academic language by asking students for explanations, maybe examples or explanations, evaluate, explain, challenge, maybe pause before taking a turn to give time to think. It's important you ask students questions, and you can ask them maybe why or how or in your opinion or do you think that? When asking students these types of questions, you give them time to think about it, also known as wait time, and then they can respond academically, and it forces them to use academic language to respond on maybe a question you ask in class. Another way to foster academic language is through conversations between students and provide opportunity to transfer knowledge and skills. So a great way to do this is just by having students work together on maybe a problem. And when they do in math, and when they're working together, they're saying words such as slope and x coordinate and y coordinate, just to explain to the other student, how they solved the problem or what they think you have to do next. You're promoting academic conversation in math and using academic terms. This is a great example here from Desmos on a way to promote academic language. So if a student you're on this Desmos question, right? And they're asked to fill in the blank of a question that says, does this graph represent a function and why? They have to use academic language to explain why that graph is a function. So it's this type of Desmos question is promoting academic language. Another thing is you could have students work together on this type of Desmos activity. So now they're conversing with each other about what they should write in the box. And last but not least, the EdTPA Central Focus. So the central focus should support students in developing conceptual understanding, procedural fluency, mathematical reasoning, and or problem solving. So these three are the key, and these three concepts are really what my central focus needs to keep coming back to and really explain how I'm going to do in my lesson. So that is my effective instruction.